So what will I have to show you? That when I apply this function to exactly to 1/4, I have to show you that the answer is absolutely 2, right? Otherwise, it's not the inverse function. When I apply this function to 1, what do I have to show you that happens? It will return exactly 0. And then I have to show you that when I apply this function to 8, the answer is -3. Otherwise, this is bogus. Okay, so let's do that. Using this very important concept, we are going to show that when we apply this function to 1/4, the answer will be 2. When we apply it to 1, it will be 0. And we apply it to 8, equals -3. You made up the function. I didn't. So log base 1/2 of 1/4 is a number unknown. I don't know what it is. But I know that this log equation can be changed into an exponential equation. 1/2 raised to whatever that I don't have yet must equal 1/4. Counterclockwise, 1/2 raised to I'm not sure equals 1/4. And now I have to think, what number I raise 1/2 to get 1/4? And there is no other way. It must be 2. If this is not 2, then I will never get 1/4. So for now, we are convinced, I hope, that y, when this function is applied to 1/4, it will go back to 2. That's what the inverse function has to do, correct? Good. Now we are going to apply it to 1. So we write log base 1/2 of 1 is whatever. I don't know. So, but this is equivalent to an exponential equation that says 1/2 raised to whatever must be 1. Okay, let's think for a moment. Exactly, this must be 0. And now we are sure that when we apply this function to 1, it does return 0. Finally, we want log base 1/2 of 8. We don't know what that is, but we know that this can be replaced by an exponential equation, which is 1/2 raised to who knows what, equals 8. Since the left-hand side is a fraction and the right-hand side is not, obviously this power must be negative, so it can flip that fraction. So what should that be? -3 indeed. So now we showed that 8 goes back to -3 through this function. So therefore, I know that log base 1/2 x and 1/2 raised to x are of each other. What word am I missing here? Thank you. They are inverses of each other. Now I'm going to ask, what about e to the x? And which function will be inverses of each other? Has to have the same base, right? So now since you said that, what about log x and very good, are inverses of each other. What about log base 7 of x and are inverses of each other? So this with this, this with this, this with this, inverses. So remember, for the exponential and the log to be inverses of each other, they have to have the same base. Okay. I would like to, I know I only have 2 minutes left. I would like to look at one domain situation. Extremely important on page 490. I would like to look at 77, and then we'll stop. $4.90. In 77, we are given f of x, which is common log, of 2 minus x. We're asked to find the domain. What did we say earlier about the log function? Is it friendly or not? And what did we establish half an hour, maybe an hour ago, about the domain of this inverse function? What did we say? Very similar to the square root, but square root allowed 0. Natural log does not allow 0. So what is the quantity that we apply log to? Can anyone read the quantity that we apply log to? It's log of, yes, common log. So log of, what do we apply log to? Then 2 minus x must be a number greater than 0. Otherwise, the function does not exist. So then negative x greater than negative 2. I divide both sides or multiply both sides by negative 1, so I get less than 2. That's how I find the domain of this function. So remember, it's a function with problems.